If you gave me one kind of magic wand wish, it would be that we could decarbonise cement and therefore concrete.
From humble beginnings as a draftsman to leading global advocate for circularity and low-carbon design, meet Stuart Smith, Director and Global Circular Economy Skills Leader at Arup, an award-winning design and engineering firm working across 94 offices in 35 countries.
What it is that buildings do that emits carbon.
It's partly about the materials, but it's also partly about the way buildings are used. You have to ask yourself, whether you can build less. The most sustainable buildings are the ones we've already built.
There is another bias that we're seeing emerge, which is timber versus concrete. What's your take on that?
Timber's not just an endless resource, neither is concrete. Nothing on this planet is. If we scale up anything, then we're going to have to watch for where the unintended consequences come along.
Well, a lot of buildings are torn down because the value of land goes up. How do I begin to anticipate or future-proof against these forces?
If you can have design for disassembly, then you can start to separate the pieces and recover the materials. It's about keeping materials and resources at their highest value for as long as possible.
What is changing in the way we build today that's going to fundamentally alter the equation?
I would say
Welcome to Ecogradia, where we meet experts and practitioners at the front lines of sustainable architecture and urbanism. My name is Nirmal Krishnani. I'm a sustainable design strategist, author, and educator based in Singapore. Low-carbon targets seem to dominate the global conversation nowadays. But how do we design a low-carbon building? The approach often centers on what to buy: the materials, the products, the equipment. What are the options at our disposal? Well, the choices can be overwhelming. Assuming we have access to data on the impact of every screw, every wire, or floor tile that goes into the making of a building, which, let's be frank, we never do, how do we push forward? A design-intelligent approach to carbon starts with time. How long will a building be in use? How much will it consume over that lifespan? What happens to its materials at the end of life? If you're like me, you may find the whole question of carbon challenging. There are just too many unknowns. My guest today, Stuart Smith, is with Arup, a multinational professional services firm that is known for solutions to complex engineering problems. He leads a structural design team at Arup in Germany, widely regarded as an expert in innovation and sustainability. I contacted Stuart because he's very knowledgeable on the subjects of low-carbon design and circularity, and I thought maybe he could unpack the carbon matter for us. A quick reminder before we start, you can get more out of this episode on our website at ecogradia.com, where you'll find curated images and notes that back up what's being discussed today. And please, if you like what you hear, click the subscribe button on this screen to know first when a new video is out. Your support matters a lot and helps this channel grow better and stronger. And now, here's Stuart Smith. Stuart Smith, welcome to Ecogradia.
No, it's great to be here. I've enjoyed our preliminary conversation in Venice, and I've been looking forward to this when we were at the Venice Biennale in November.
So thank you for making the time to be with me. Now, you are a structural engineer by training. You perhaps more than most understand material choices. Let me start with a burning question. What is the one material innovation in the pipeline today that will, in the next 5 to 10 years, say, significantly lower the impact of buildings?
I would say, the material that we use most of in construction is concrete. And in concrete, there's a lot of cement. And cement is the generator of a lot of carbon at the moment. And the industry is working very hard to change that. And we really do need to change that because we've got a lot of building ahead of us. We've got another 3 billion people coming onto the planet by 2050, according to the UN. We've got 1.1 billion people already living in inadequate housing due to rapid urbanisation and the planning of that since the 50s. And so it's really not a viable position to say we're not going to build anything, or in the privileged position perhaps we have in Europe that we're just going to retrofit the buildings we've already got. We have to figure out solutions for how we're going to use materials into the future to provide this. First of all, the basic need of housing, but then all of the things that go with it. So if you gave me one kind of magic wand wish, it would be that we could decarbonise cement and therefore concrete.
Are you saying then that in the next 5 to 10 years, we are likely to see a carbon neutral concrete or cement?
Of course, it's also about it being scalable. So you might be able to throw enough technology to make in the lab a carbon neutral cement, but trying to scale that so that we could use that on every project at the moment, that's not foreseeable. So it's more likely that we'll be working around process improvements, because of course the cement manufacturers are still trying to make a business, and there's only so much the market will pay for their product. But there's a lot of innovation going on. There's a lot of opportunities to improve the position, and there's a roadmap for the industry to reduce emissions quite substantially by 2030. But then beyond that, the sort of deep dive is carbon capture and storage, and that is a technology that's still being developed and still being deployed at scale.
If we do get to a point where carbon neutral cement is available, what does that mean for emissions globally? I mean, do you have a sense of what would change as a result of that?
Yeah, I mean, if you I'm going to round up the numbers a lot, but just to kind of give you some perspective, we could say we've got 50 gigatons of carbon being reduced, emitted into the atmosphere. We need to be able to halve that fairly quickly to 2030 in terms of the buildings emissions, half of that, and then 2050 to get to net zero. So our contribution as the building industry to that, we have the number in our head of about 40%. So if you broke that down into where that sits at the moment, of course, there's a lot of buildings. The built environment's already got a lot of buildings that are built and in operation, and they're using up, say, 9 gigatons of that. And then the materials industry, construction is probably about 3 gigatons. So from that 40%, probably about 30% of it is buildings in operation, and 10% of it is in our materials. So I just rounded up the numbers a bit there, but that shows you how significant materials are now in the built environment. What we're trying to do by 2030 to meet those targets is get to a point where our buildings are net zero in operation, and where we've reduced the embodied carbon, so that's all of the carbon in the materials and the construction, by 40%. So there's a lot of work to do there. That's an ambitious target, and there's many measures that we're looking at to try to get there. And we can talk through some of those. There's no one magic answer to all of this. There's a whole series of responses, and they can also be very location specific as well.
Sure. Well, let's unpack the question of carbon step by step here. Break it down a little further. Talk to me about what decarbonisation means and why it's important.
So in terms of why it's important, I think a reference that I've used a lot to try and explain to people some of the issues around materials and why it's important. There's a Canadian photographer called Ed Batinsky, and he photographs landscapes where we've made a big impact. And some of his pictures are they're very beautiful pictures, but they're also very dramatic. The most dramatic one I would refer you to, and it's worth looking up, is an image of nickel tailings. So it's a blackened landscape with a red river, the red coming from the nickel, running through the environment. And when you look at these pictures, you see the impacts that we're having, and you realise that what we're doing in the materials industry is having an impact elsewhere. When I saw this picture, I went off to try and find, what do we actually use nickel for? And I found that it was often used in stainless steel. And stainless steel, of course, is a product that we specify in buildings all the time. So generating that awareness and that sense, which I think is coming when I started this journey, looking at the topic of materials and the impacts that I had offsite some 10 years ago, it wasn't such a conversation. But now, of course, it's centre of developing sustainable buildings and sustainable ideas. So there's the offsite impacts of materials, but then, of course, the climate impacts. I'm living in Berlin, in Germany at the moment, and the extreme weather a couple of years ago caused flooding in the west of Germany like we hadn't seen before. And those impacts then of extreme weather events are coming, very close to a lot of people. already been experienced quite significantly in other parts of the world. And if we continue on the path that we're taking, then of course global warming's going to have a massive impact on all sorts of things. Sea level rise, of course, heat temperatures in Africa. I was listening to Johan Rockström, climate scientist from the Potsdam Institute of Climate Change, talking about the potential, if we don't resolve the problems, to have to relocate people from say sub-Saharan Africa, and the impacts of that just unimaginable. We see how difficult it is to move people around from some of the very unhappy scenes we see around refugee crises and so on, and just imagine that at scale with climate change. It's it's catastrophic. So that's the of course the bit that's always there for us, the awareness of that. But I would pivot to say, that gives us a huge challenge and an opportunity, because I do feel like the global community has started to mobilise a lot to do something about it. We're still a bit slow. We've still got so much to do, but it's starting to happen. So we've got an opportunity through dealing with carbon to change a lot of other things as well at the same time.
Talk about what it is that buildings do that emits carbon. So if I had to break it down into when and how does a building emit carbon,
Sure.
what would that be?
Yeah. So broadly, a well-designed building today, the carbon would be about 50% in the operation, so all of the heating and electricity and so on, and about 50% in the materials. So they're and that's buildings well designed today, and about 30% of the materials carbon is in the construction and the building and the materials supply. So that when you actually put the building up, what we found from our data analysis was that about 20%, so the other bit of the embodied carbon, is in the fit out and the change of buildings over time. So you're tearing things out, particularly in commercial buildings, which are changing quite quickly, and creating another 20% of embodied carbon. And that, to me, is a really good opportunity as a place to start, alongside the harder to deal with, harder to abate items like primary structures being built in concrete. So that broadly, that gives you a sense. This data or this analysis came from a report that we produced, which is also worth looking up, with the World Business Council for Sustainable Development. Where do we stand? And we took embodied carbon. Where do we stand? And we took 5 of our projects and we analysed them to see where the carbon was in the projects. And that was one of the findings. That was quite a lot in the fit out and the churn and the change of a building over time. And one of the other things that was quite interesting, there's quite a lot of carbon in the MEP, the mechanical, electrical and public health. So all of those systems, which are very difficult to identify where the carbon is, and we're still working on that. There's 20% there. So, but the majority of the carbon's still in the structure and the facades, so the basic shell and core of the building.
So there is one component, which is the embodied carbon, which is the material and the construction emissions due to material production and manufacture. The other is to do with operational emissions, which is the energy that a building uses in everyday operations across the life of the building. In many cities, like Singapore, for instance, I don't have a choice of the energy mix of the electrical power that I purchase. It may be dirty or it may be clean. Yeah, I don't have a say. It depends on the state or it depends on energy companies. So what can I do to bring down our operational emissions?
Well, you're always going to start with the more passive things that you can do. So designing a well-insulated facade, providing the right solar shading, and then looking at what passive systems you could employ in terms of natural ventilation and so on, before you actually add any cooling. And then you would look to see, once you've gone through all of those measures, you're obviously going to still have some amount of cooling, heating, some power requirements and so on. you can start to minimize the demand through the efficiency of the systems that you choose. And then once you've reduced that as far as you can, you then can start to look at what you might generate in terms of renewables on site. That can be quite tricky in a city. You're perhaps much more likely to look at that at neighbourhood scale or city scale, which, as you say, is not so much within your control.
What about embodied carbon? Same problem. I don't I don't have control over supply chains, and many suppliers, I mean, particularly in places in the developing world, in Asia, for instance, simply don't offer the data on embodied carbon in a product. So what do I do?
Yeah. So we've got again another hierarchy. So in terms of embodied carbon, if you can be reusing an existing building, and that for some of our clients, for example, that might be actually the way they're using their existing buildings and improving the way they're using existing buildings. So before we even start a project, looking at whether that's a project that's really needed, because obviously the I think we're now saying, the most sustainable buildings are the ones we've already built. So can we repurpose and retrofit them? And there's I think the condition in Europe is very much focused on that as in new typology, either change of use or reuse or upgrading or whatever it might be. And I've for a long time admired the work of Lacaton and Vassal, who now, of course, are very well known, having won the Pritzker Prize.
Winners, yeah.
Exactly, yes. But with a mantra to never demolish, and they've really shown what you can do with existing buildings. So as a starting point, you have to ask yourself, whether you can build less. And then once you've done that, you've really got to make sure that you're building efficiently. So when you come to scheme a project and a building, there's quite a few choices, obviously, that you're making at that point, which then get locked in. So for a long time, the building industry has used concrete flat slab construction. And concrete flat slab construction is easy to build and very easy to coordinate with the rest of the building. It's just a simple flat concrete slab. But it's probably only working at about 30% of its capacity. So what we've understood, and these projects have been built, are still being built actually, but we've started to look at how can we change that. So some simple things, for example, bubble deck is a system, a concrete slab system where you have voids within the slab in the middle where the concrete's not really working. So you're replacing concrete with air. And then the concrete slab doesn't have to carry the load of the concrete that you've replaced. That's a very simple example. But then you can take it a bit further. And if you really could just put the material where it's needed, then a concrete slab that's, say, 30 centimetres thick would become 10 centimetres. That's an example of where by designing efficiently, you can reduce your embodied carbon. And coming back to where is the carbon, a lot of it is in the floor plate of a structure. So if you build a concrete building, in the floor plate, if you can only use the material you need, you can reduce that impact by from down to 30% of what it was. So and so on and so on through the, and then when you get to the end of that, you've done all of those things. You've then got material choices to make, and you could, for example, you could start to look at how you could replace higher carbon intensive materials with lower carbon intensive materials. So timber would be an example of that.
Right.
And in Germany, we've developed with the industry timber concrete composite slabs. So using timber beams and just a 10 centimetre concrete deck. Very good example of that is H7 in Münster with Andreas Heupel, which is one of the early examples of that.
Right. Can I play the devil's advocate? One of the challenges of retrofits is, of course, that you don't get the same performance out of the building that you would if you were building anew. So I know there is a strong movement in Europe towards retrofit, but sometimes old buildings are just poorly designed, or if they were designed like this in the 70s and 80s, they were really designed for air conditioning, and there's no way to reverse that. So the question I have for you then is retrofit always better?
What I'm against is saying is having absolutes like that. Is retrofit always better? Is timber better than concrete? You know, those kind of big statements. I think what I'm advocating is that we've got a lot more information, a lot more data now, and we've got the tools, and we're certainly developing more of them as we speak to do that analysis and to figure out which one's better, and to approach each project and figure out what the virtues and benefits are. So I think you could say in many cases, and in Europe we're definitely pushing towards renovation, and it's important. I think in the UK as well, you know, we start with planning law. We're starting to say, you know, you've got to have a really good reason for knocking a building down now, which is forcing people to do that work and take a breath and consider a project for its specific location, to do the sums and see whether the operational or the embodied carbon is a driver of the project. But I would also say, you know, we're looking at projects now where we have decided to take a building down, but we're much more thoughtful about how we do that, and trying to reuse the materials and put them into secondary material chains, and perhaps even reuse some of the materials in the new project. And you're starting to see that, but at the moment, it's still, I would say, experimental, and it's people with a real passion to do it. But I really hope, and we're doing everything we can to facilitate it, to be able to scale it up, the secondary materials and the way we use and reuse components. I would give you the example of the Holcim Foundation Gold winner from 2021, which was a project called K118, which was the last piece in an industrial transformation. And the Architect Bureau Bau in Situ worked very closely with the client over a long period of time, and came to this as the last project of the piece, and persuaded the client to embrace this idea of reuse of secondary materials. But then they went themselves and scouted all of the materials. It's in Winterthur near Zurich, and through their passion and their knowledge, they found all of the materials, salvaged them from different sites that they knew were coming down. In the future, we would like to be able to make that process much, much easier, so that if we've put materials into the built environment, they stay there and they don't end up being crushed and wasted. So, you know, to put some numbers on waste from a city, about half of it is coming from construction and demolition waste, and there's a very small proportion of it is actually reused in its current state. A lot of it's downcycled. So reclaimed steel, for example, only about 5% of reclaimed steel is reused in its original form. The rest of it goes back into the process, which of course takes energy to be reformed. So we need to create much better secondary material markets, and it's happening. There's some really good examples of it happening.
There is another bias that we're seeing emerge, and you touched on that briefly, which is timber versus concrete. That there is a kind of, in the sustainability circles, good versus evil, kind of almost cliche of how we think about this. And I've had a couple of guests on the podcast from Latin America who build mostly in concrete.
Yeah.
And they tell me why. They tell me that it makes sense from the point of view of the climate and the context and the availability of materials and so on. And I wonder if you could talk a little bit about that, because I mean there are obviously different things to consider. There is the carbon issue, which is timber, emerges better than concrete, but there is also the durability issue.
Yeah.
What's your take on that?
Yeah, I mean, I would agree with that. I think you've got to be location specific with your project. Again, we can't say timber's going to be the answer the construction industry's problems, and I would worry about that as well, because if you suddenly try and build, as I mentioned earlier, the 3 billion people that will need housing, if you decided to do all of our construction henceforward in timber, you would clearly create some major problems in terms of supply. Where's that being grown? What's the landscape? What's happening to the landscape? Go back to Ed Batinsky and he'll be showing us photographs of where we've chopped down forests all over the place. If we scale up anything, and if it's timber in construction, then we're going to have to watch for where the unintended consequences come along. So one, for example, timber's very complex to actually figure out the carbon cycle. We've on some of the projects we've been assessing, we report the biogenic timber gets reported separately, and we're treating timber as carbon neutral on some of our projects. Because there's very much an end of life scenario. So if we're storing lots of carbon in timber, and then we build lots of buildings in timber, and then we end up not replanting the timber, or we end up releasing the emissions back into the atmosphere, we could conceivably be storing up other problems for future. So it's important to use some common sense and get some, timber's not just an endless resource, neither is concrete, neither is water, nothing on this planet is. That's one of the important points. We're living with finite resources, and we need to start behaving like that and designing like that. So where you've got a really good timber industry and a great supply chain, timber's a great building material. But where you don't, we still need to focus on decarbonising concrete and cement to get to the point where we can build. And that's a very local material as well. It's it's popular for a reason. It's actually, if you look at it by weight, it's actually a very low carbon material. But the issue with concrete is we use so much of it.
Right.
As I said, the second most used material after water. So it's the fact we've scaled it up, and again, maybe an unintended consequence.
So much of what's happening in the developing world is driven by new build densification.
Yeah.
Well, a lot of buildings are torn down because the value of land goes up, or the allowable density goes up. So there is a whole economic logic to how things are being torn down and built. I mean, how do we thinking as a designer? How do I begin to anticipate or future-proof against these forces? What are the things I need to think about at the beginning of the design process that kind of preempts some of these shifts in land value and how building stocks are assessed?
When I've worked on some major master plans, so I worked on a master plan with Rem Koolhaas in London, White City, and that's 20 years ago now. But this is the kind of timeline for master plans as well. At the beginning, one of the things we identified was the scarcity of land and the need for density and of course density in our cities, and also creating a mix. So it goes on to thinking about the implications of transport, the 15-minute walking city, and how we create density and a mix of uses and so on. So we're creating neighbourhoods into which our buildings sit rather than individual pieces that stand alone. So I think that's an important, connection to transport, location, making sure we've got the right mix. So it's a slightly broader issue in terms of planning and for the future. But what I would say in terms of tall buildings, there's very few have actually been demolished. I think there's only about 10 buildings over 200 metres tall that have been demolished. Really? And I would like us to start to see tall buildings as kind of fixed infrastructure in a city. If you put up a tall building, it's a fixed point, and you might reclad it or upgrade it and so on. So that would bring us on to thinking about projects from a alterability or flexibility and alterability in the future. I think I just made alterability up as a word, but anyway. But I would cite as a good example Leadenhall in London, the cheese grater nicknamed the cheese grater with Richard Rogers. That was, again, with Lang O'Rourke, I mentioned earlier, a very innovative contractor. And we designed them and built that with 80% offsite construction. Mm-hmm. And that's a 220-metre tall tower. And the architecture, of course, of Richard Rogers is very much about components that come together. So we were able to build up bigger components. So for the cores, for example, we built components about the size of a bus and put those into place in one lift. So the implication being there that if you design something that can be assembled like that, you could also reverse the process, and you could have therefore design for disassembly. And if you can have design for disassembly, then you can start to separate the pieces and recover the materials. Now, you might not, for that building, take it completely apart, but you might take parts of it apart, and then you might interchange and upgrade it over time. So the sooner we start to design buildings that can be changed and adapted over time through the way we approach putting components and pieces together and so on, then the sooner we'll be able to start to upgrade our what I would call, with tall buildings, almost infrastructure over time, the fixed parts of our city.
There is a lot of conversation around the question of disassembly and how we design in a modular way that then extends the life of the components, that, the component lives on beyond the demise of the building, so to speak. There is also conversation about adaptability, which is to say that, buildings get torn down because they are obsolete. And therefore, if we can design buildings to have easy change of use, for example, then that again, goes to the extension of the life of the building. My big struggle is with density, and in my teaching, for instance, I often ask students to design buildings that can be densified. So you have a mid-rise building that can become a tall building, in time, because you need more gross floor area and so on. And I think what that leads you to is a position on capacity buffer. So the building is over-designed to begin with. The structure or the foundation is more than it needs to be for what it is in the medium term, because you just don't know what the long term is going to be. I mean, is there a train of thought along those lines that you've heard of where buildings become future-proof because they anticipate densification, not just change of use?
There's a very good example that we've done. It wasn't necessarily the intention, but it points the way. There's a project in London, number 1 Triton Square, which we designed 25 years ago. And therefore, we've got all of the drawings and all of the information and so on, which is a key part of this, which we don't necessarily have for all of the built environment. So we had all the drawings, and we were asked by the client to increase the floor plate area by double. And to do that, and it had, as you mentioned earlier, it had quite a big atrium space, so we took advantage of that. It didn't have the foundation capacity, so we had to upgrade the foundations, but you can do that, and some of that you can be building into the design at the early stages. It's a balance between obviously the embodied carbon and the impact of building in something extra at the beginning, as opposed to what you might therefore facilitate later on. But in that case, we were able to increase the building by double in terms of floor space, using lightweight construction, a little bit of strengthening. And the facades, we took facades off, we took them to a local pop-up factory, and we refurbished them and reclad the building with the same facade. So if we could design to make that easy in the future, as you just suggested, I think that would also be a big step forward. And there's an example of where we've done that. Yeah,
I have one more question about the idea of design intelligence, which you alluded to, which is how do we design rather than just take a kind of a blanket view that this is good or that is evil, really to think about things in a more sophisticated way. And I'm reminded of a project in Sydney, Australia, the Atlassian. I don't know if you are aware of it. It's a very interesting project because it hybridizes timber and concrete. So the core and the slabs, every 6 or 8 floors is made out of concrete, but then the infill between that is made out of timber, and then it's got this steel exoskeleton. So the goal here is to reduce the embodied energy, embodied carbon of the project by reducing the net amount of concrete and steel. But it creates a whole new typology. It creates a whole new way of looking at high-rise buildings that I hadn't seen before. I found that really exciting. I wonder if you have other examples of buildings that are pushing design intelligence, not just an either-or question, but really how to hybridize better.
Yeah, I mean, as the example I gave you earlier, H7 or H7 in Munster, which was at the beginning of that timber concrete composite wave, just trying to bring new products to market, and that idea of mixing timber and concrete is still being explored, and I'm seeing it a lot in projects in different locations. You know, if you've got a fixed concrete core and floor plate for a building, and then in between you can create variety and change and flexibility.
Right.
And looking at ideas to be able to, you know, on a recent high-rise project, we looked at the idea of removing parts of the floor plate in the building, because quite often it's the connection between floors that creates that creates an issue. So being able to do that easily in a high-rise building to create kind of vertical neighborhoods, I think is could bring a longer life to these buildings, more flexible uses. So it's partly about the materials, but it's also partly about the way buildings are used, the way high-rise buildings are being used. And the other thing you'll see is a lot of people trying to bring more humane and natural environments into high-rise buildings. So a lot of effort to bring nature and green into buildings. Of course, Bosco Verticali in Milan was an extreme example of that, literally a vertical forest. But you know, we see that in a lot of projects.
Thank you for expanding the conversation to not just materiality, but the quality of the built environment. I think that's a really important thing to not forget, that at the end of the day, these projects are really meant for humans and our relationship to natural systems. I have one last set of questions relating to carbon, and this is, where do I go? And you kind of mentioned the Arup database earlier, the projects that you've collated. Where do I go? Is there a 1 or 2 stop the online portal where I can get in data on carbon that would help me guide decision making?
Yeah, so whole life carbon analysis or whole life cycle analysis. There's a tool, one click LCA, which I'm sure you come across at some point, and that's a database that's been built up over time. I think from 12 European locations. So there's a fair amount of data in there. What we're starting to do at the beginning of a project is, and I would advocate this for every project, is to try and build a small handbook of different solutions, picking out the data that is available, and perhaps filling in the gaps with data that might come from other locations or other sources, but use it as a proxy. So you know, you just take some time to assemble that. We've done that for a couple of projects where we've got a quick comparator, say, for different floor plate solutions, to allow us to make comparisons between different structural solutions.
Right.
To try and bring things, you know, right into the design process rather than wait till the end and then use tools like one click to see where you are.
A lot of the carbon tools that you come across tend to be very time intensive, and you've almost got to have, you know, you need to have made all the decisions about the screws and the wiring and the windows and so on. But are there conceptual tools? Are there tools that let you think about this at the drawing board at a very rough, the proverbial architectural sketch? Yeah.
Yeah, this is. I mean, ideally, our database, our platform Zero, which is collecting all of the data that we're gathering on these projects, we'd be able to make that available. there's some issues around confidentiality of information and so on. And also as it builds, seeing how reliable it is. But in the future, that platforms like that should be able to guide us through that process. And we can also start with kind of, the first level of information is that conceptual level, and then progressing through, and that giving us the feedback loop to see, whether the decisions we made at the beginning are holding for a project. So those tools are coming. The data bank's starting to grow.
Right. You talked a little bit about, the kind of digital fabrication. What is changing in the way we build today that's going to fundamentally alter the equation?
Yeah, I think if you look at construction productivity over time, this is very well known that it's relatively flat compared to manufacturing, for example. And if we and that's with rapid urbanisation, as I mentioned earlier, there's a lot more people living in cities now, in many cities in informal settlements and so on, because the construction industry can't keep pace with the need for housing. And that's not just, that's a problem in Berlin, it's a problem in Copenhagen, it's a problem in London, it's a problem all over our cities. So we need to be able to build much more quickly, and at the same time, do it with less carbon, half carbon now, zero carbon in 2050. And we need to do it in a different way so that we can recover the materials and keep them at the highest value. Not a small challenge, I would say. But offsite manufacture and digital manufacture are two of the components we can use. So offsite can increase productivity. If we look at the timber concrete composites, they're made offsite, they're erected very quickly, and they're quite light. Next step would be to be able to recover those materials or reuse the components elsewhere. Digital manufacturing allows us to put the material where it's needed. So 3D printing, for example. But that's not just a solution in the global north. It's also global south, with 3D printed houses now appearing in parts of Africa, and the Chinese have been experimenting with that as well at scale. So there's all sorts of impacts in the way that we're building and constructing, and I think offsite is one of the keys, because then you can really take construction into the factory and get it built much more quickly when you bring it to site, and be much more deliberate about the material choices, the way you fix components together. On site, it's a lot harder to do that. That's why in situ concrete is very effective in current construction industry. And concrete's definitely got a part to play in the future. 3D printed concrete floor plates could be, for example, build those in the laboratory, in the factory, and then put them into components in buildings and be able to recover them at end of life. We're stepping a long way towards solving some of the problems we face there.
Just give me a sense of what this looks like in practice. I mean, what is the potential impact of 3D printing? What could it mean for carbon? What could it mean for the efficiency of material use?
Yeah, so construction industry at the moment is based on, whether it's using flat plates of steel and cutting them up and welding them together, and then designing them so that, you've got high stress in some parts, but probably pretty low stresses in other parts. Same with the concrete floor plate, as I mentioned earlier. You've got some high stresses in some parts, but quite a lot of it's not really doing very much. And if you can change that so you can actually just put the material where it's needed, which is 3D printing and digital design and manufacture, then you can save probably on most components. You could probably save at least half, but tending towards 30%, which is the kind of reduction we need in our built environment in terms of our material use. So it could have a really major impact.
Right.
And we've done some studies that verify that on different building components. So really potentially quite a big impact once we can scale it up. It's issues around speed of production still in terms of 3D printing and so on, but the technology is definitely there.
30 to 50% reduction in material use. That is a lot. That is impressive.
Yeah. So very simply, that reducing embodied carbon, reducing material use,
Sure.
and also a route to putting the materials back into the process as well. So if you've 3D printed something, quite likely you can just remanufacture with the same material when the time comes.
Right.
So it's it's a win-win, really.
Before I wrap up the recording, I do want to ask you a little bit about your journey. How did a structural engineer become a world-leading authority on circularity and carbon? How did you get here?
I started actually as a draftsman, and I think that kind of very practical and pragmatic start to my career is something that's really stayed with me. So really understanding the building industry from those first principles, and spending time going onto sites and doing lots of detailed calculations and so on, before kind of looking much more broadly. I really encourage my younger colleagues to kind of have those experiences to build up their practical knowledge, which is sometimes missing from the conversation, right? It's that pragmatic, practical knowledge which the building industry really demands.
Yes.
Before you can then start to think about how it could be different and how it could change. But always, as I said earlier, in my mind, thinking what we're doing is not sustainable, but I don't know the answer. And so always searching for that answer. And then, for me, a big part of my journey was joining Arup as a multidisciplinary consultancy with so many colleagues from different perspectives and so on, and learning so much from each other. That multidisciplinary environment, and Ove Arup and his vision for multidisciplinary design and bringing people together to get the best. I think that's a very powerful, whether it's in one company or whether it's as a design team working together, it's a really powerful way of approaching things.
Yeah.
And I suppose coming to the circular building and the principles of circular economy, which really opened my eyes to solutions that I then became increasingly passionate about over the last 10 years, and sought out a big network of collaborators so that we could continue this conversation, learn from each other, develop projects. I would really hope that we don't lose sight of projects as a lighthouse example, and doing our best work rather than authoring codes of practice and so on, which is important. But the projects are so important to me. I've tried to stay as close to them as I can.
Last question, Stuart. What gives you hope?
Well, conversations like this. I really think you've got, as we pivot at the beginning of our conversation from the impacts of climate change and how terrible it is, to what we're going to do about it. And I do feel like there's a community now of people who are engaged and understand the problem and really want to do something about it. And you're finding that everywhere now. So there's a lot of hope in that we are going to create great cities, great built environment, employment for people. We're going to decouple our economy from resource consumption. I really am hopeful that these things will come to pass and that we'll see them within the next 10 years substantially manifest.
Wonderful. Well, on that note, Stuart, thank you so much. It's been a great pleasure. It's great fun talking to you.
Thank you. Yeah.
Yeah.
I kind of wish we could do another couple of hours now, but you probably don't.
Don't tell me.
No, it's great. It's been great.
No, thank you.
I really enjoyed it. Thanks, Neville.
Well, I hope we get to meet again soon. I mean, if you're coming to Singapore, that'd be great.
I will certainly look you up if I'm in Singapore.
Brilliant. Well, thank you again. I'll see you soon.
Thanks, Neville. Bye.
I'd also like to thank you all for tuning in. There is much more about this episode waiting to be unpacked at ecogradia.com, where you can also find all past episodes, their images and notes on dedicated pages from season 1 up to now. If you enjoyed today's conversation, please click the subscribe button on this page to know first when a new video is out on our channel. It means the world to us and helps us reach out to more experts and practitioners with ideas and solutions on how to make this world, buildings and cities, more sustainable, one blueprint at a time. Until we meet next, this is Nirmal Krishnani signing off in Singapore.